everyone, welcome back to my YouTube channel. My name is Noy from ADDIS University. Today I'm going to tell you how to solve this problem. As you can see, this problem is all about projectile motion. You are familiar for projectile motion. Projectile motions is a two-dimensional motion. Projectile motions has independent vertical and horizontal components of velocity, and you can use the concept of projectile motion for the vertical, and we can use the concept of uniform motion for the horizontal, which means horizontal motion of a projectile motion is an example of uniform motion, and the vertical motion of a projectile motion is an example of uniformly accelerated motion. For the case of uniformly accelerated motion, the acceleration is constant and the velocity is varying at a constant rate, and for the uniform motion the speed is constant and the acceleration is also zero, which means on the horizontal acceleration is zero for projectile motion, and the vertical acceleration is constant for projectile motion, which is acceleration due to gravity, which means it is 9 meters per second square. We can calculate the velocity, distance, and times, simply the motion parameters for a projectile motion by using the equation of uniformly accelerated motions and the equation of uniform motion, which means when the speed and the accelerations are constant respectively. For this problem, we are asked to determine the angle of elevation. In order to calculate the angle of elevation, we can use the equations of the path of the projectile motion, which is the trajectory, and we can simply solve this problem easily. Okay, before starting this problem, if you are new educational tube, make sure to subscribe our YouTube channel and access a free engineering problem solution, and also a free tutorial that are very important for high school, preparatory, and university students. Now let's jump into this problem and show every single step on it. The muzzle velocity of a long range rifle at AAZO 400 meters per second square. Here we have a velocity of 400 meters per second square. Determine the angle of elevation theta, which will permit the projectile to hit the mountain target at B. As I told you before, you can use the equation of the trajectory and you can simply calculate the two angle theta. So first we must know the given quantity. We are given the initial velocity is 400 meters per second square, not 14 here. You can correct it by yourself. 400 here we have 400 meters per second square, and y is equal to 1.5 kilometers per kilometer. Simply here is height is 1.5 kilometers, and which is 1,500 meters, and the angle of launch from the equation of projectile is given, which is y is equals to x tan theta minus gx square over 2 square plus 1 plus tan square theta, which is a given equation. We can simply substitute the given value on these equations and determine the required angle theta. So it is very simple problem. It is a matter of substitution. We can substitute the value on these equations, and after finally we can use the equation of quadratic function, and we can solve it, and we can get to angle theta. So it is very easy equation. Y is equals to 1,500 meters equals to x is 5,000 meters, which means 5 kilometers is 5,000 meters, times tan theta. Tan theta is also the required angle, minus 9.8, which is g times x square. X means 5,000 kilometers square over 2g, which 2u square, which means 2 times 400 meters per second square, not 14 here. You can correct it by yourself. Plus 1 plus tan square times theta, which is the required one. So after simplifying this equation, you can get your answer simply. It's very easy equation. So when you can simplify it further, we can get 1,500 equals to 500 meter times tan theta minus 766.4 minus 766 tan square theta. When you rearrange this problem, 766.4 tan square theta minus 5,000 meter tan theta plus 2,266.4 degree is equals to 0. After simplifying this problem, we will get this, and finally you can use the equation of quadratic formula, and you will get your angle theta equals to 6.03 and theta equals to 0.949. It is a matter of substitution. If I am mistaken, you can correct it value set, because you can substitute the given value here on this equation.